Imagine a night sky full of stars, hundreds of billions of suns in our own galaxy, and around them, possibly trillions of planets. Logically, we should see signs of life everywhere. Twinkling cities on alien worlds, signals from extraterrestrials, perhaps even ships flying between stars. And yet, silence. The night sky seems empty and silent. Where did everyone go? Are we completely alone in the cosmic void? This question of where they are is at the heart of the Fermi Paradox. At first glance, the answer seems simple. The universe is vast. Distances between stars are unimaginable, and we are just beginning in communication technologies. After just 100 years of travel in space, our own radio signals become so weak that it's difficult to distinguish them from background noise. Maybe we don't hear the aliens because they are too far away? Maybe we don't see them because no telescope is capable of spotting cities on distant planets. After all, so far, we've only sent people to the moon, and the farthest probes have barely left our solar system, moving at a turtle's pace on a galactic scale. It seems logical. The lack of contact might not be strange at all. And yet, the Fermi Paradox has its true version, formulated by Michael Hart in 1975, and that is why it is sometimes called the Fermi-Hart Paradox. And this version poses a much more difficult question. Let's imagine our civilization in 1,000, 10,000 years. If we survive and continue to develop technology, we will probably colonize Mars, the Moon, maybe Jupiter's moons. In 100,000 years, we might send ships to nearby stars. Colonizing the galaxy is really just a matter of time. Even current science does not see any insurmountable obstacles. We can build bases, terraform planets in the future, construct interstellar arcs. Indeed, there are ideas for Dyson spheres or giant Dyson swarms, which are swarms of satellites surrounding stars to collect almost all of their energy. After all, Earth receives only a tiny fraction of the sun's radiation. A more advanced civilization could use the rest by building a massive swarm of solar panels around its star. With energy comparable to the entire power of the sun at our disposal, interstellar travel would become much easier, even if lengthy. And now multiply that by billions of stars. If we can imagine it, then other hypothetical civilizations could as well. It only takes 1 in a billion planets to give birth to intelligent beings who desire to explore and colonize space. Only 1 in a billion. And the Milky Way should have been teeming with life long ago. Just one ambitious civilization that emerged 1 million or 100 million years before us would be enough to spread its colonies throughout the entire galaxy. 100 million years is not much on a cosmic scale, yet enough to conquer every corner. In such a galaxy, we wouldn't have to look for radio signals from a single world. We would see traces everywhere, stars surrounded by structures, interstellar fleets, maybe transformed planets. Such a galaxy would resemble a lit-up Manhattan rather than a wasteland. It would be hard not to notice a galaxy-type civilization. A Type 3 civilization on the Kardashev scale, which uses the energy of an entire galaxy, would alter the appearance of its galaxy so much that astronomers would have spotted something unusual in the data long ago. Yet, despite increasingly better telescopes, we see nothing obvious. No megastructures blocking the stars, no suspicious uniform signals in the cosmic background, empty. That's the Fermi Paradox in all its glory. If the cosmos offers such immense possibilities, why is there no evidence of anyone using them? Many answers have been proposed, from ideas that aliens are hiding or observing us from a distance like animals in a zoo, to suggestions that maybe everyone is in a computer simulation and isn't interested in the physical universe, to the concept that intelligent species prefer to stay quiet like mice because something bad lurks there in the darkness. It all sounds a bit like science fiction. Each of these explanations has weaknesses. It's hard to imagine that every civilization, without exception, simply doesn't want to explore, or that contact is prohibited everywhere. More and more scientists are leaning towards the idea that perhaps intelligent life is extremely rare. Maybe in our entire galaxy, we are the only technologically advanced civilization, at least for now. This idea leads to the hypothesis known as the Great Filter. It says that on the path from the emergence of life to the colonization of the galaxy, there must be a very difficult step, a barrier that almost no one overcomes. Somewhere between a dead rock and a galactic empire, there is a filter so effective that almost all potential life does not get past it. It may concern the beginnings of life, the development of intelligence, or something that awaits us in the future. If such a filter exists, it would explain why we do not see aliens. Simply put, almost none have gotten as far as we have. Or, it's a terrifying thought. All those who succeeded have already eliminated themselves. Let's look at 3 possible great filters that may explain this paradox. Each operates at a different stage, from the origin of the universe, the birth and development of life, to the scale of cosmic time. The first great filter is a finely tuned universe. Let's start from the very beginning, with the rules governing reality. Scientists have discovered that fundamental physical constants, such as the force of gravity, electromagnetic interaction, and the mass of elementary particles, have values ideally favorable for the formation of stars, planet, and life. If gravity were even slightly stronger, stars could collapse into black holes, and planets would not form at all, or even if they did, too much gravity would crush any larger animal. Imagine that even bacteria would collapse under their own weight. Conversely, if it were a bit weaker, matter might not clump together into stars. We would have only dispersed gas. Similarly, it is with other nuclear forces constants, the electron charge, the Planck constant. It seems our universe is like a violin perfectly tuned to play the symphony of life. The margin of error was tiny. A small change in life, at least as we know it, would not at all existed. So why do we live in such a favorable universe? Some say because otherwise we wouldn't be here to ask these questions. This is known as the anthropic principle. Others suggest it is a divine plan or intelligent design. Someone specifically set the values of the constants so we could arise. Still others prefer the option of a multiverse. Perhaps there are many different universes with random parameters, and we just hit the jackpot in the cosmic lottery and ended up in this one. Out of a billion, one is suitable for life. It strokes the ego, doesn't it? We won the lottery of existence. Of course, we need to calm down here. The fact that our universe allows for life doesn't mean it is maximally friendly to life. If a force governing reality were solely interested in creating life, one might expect life to be everywhere, non-stop, from the very beginning of the cosmos to its end, and this is not the case. In reality, the vast majority of matter in the cosmos is empty space, gas, rocks, and fiery balls. The environments are rather inhospitable. For the first hundreds of millions of years after the Big Bang, life could not exist because there were no heavier elements. Initially, there was almost only hydrogen and helium. Only when the first stars in their nuclear furnaces produced carbon, oxygen, nitrogen, iron, and exploded as supernovae did they enrich the space with these elements. Only then could planets similar to Earth be formed, with the rich chemistry needed to build, for example, bacteria. Our universe may be well-tuned, but it does not spoil us. It gives life a chance, but it doesn't roll out the red carpet for it. And nevertheless, the fact of such tuning is intriguing. Is this already the great filter? If the physical conditions after the Big Bang must be in a very narrow range for stars and life to exist at all, then we can say that we have already passed the first sieve. We simply find ourselves in a reality that has gone through this stage. A universe with bad parameters wouldn't even witness beings that could wonder about the absence of alien civilizations. We exist because we're lucky. How many other universes were barren? We may never know that, at least not in this life and not on this planet. Incidentally, there are also exotic considerations. Since our universe is so large and long, theorists ponder truly crazy scenarios. For example, the concept of a Boltzmann brain suggests that, given infinite time, purely random fluctuations of atoms could form an animated brain full of memories drifting in space. It sounds absurd, and in a way it is, but it shows one thing. Chance rules at a fundamental level. If you give it enough time and matter, even the most improbable event can happen. Of course, we don't assume that we will encounter an alien civilization made up of brains randomly glued together flying in space. This is more of an intellectual curiosity for physicists than a real plan B for life. So let's return from these metaphysical musings to our real cosmos. The second great filter, the rarity of intelligent life, even in a hospitable universe like ours. Conditions must align perfectly for life to appear, let alone to evolve into intelligent and technological forms. Let's look at our own home, Earth. Life on Earth arose quite quickly after the planet formed and cooled. There is evidence of living organisms from over 3 billion years ago. This may suggest that when conditions are favorable, life can spark relatively easily. But for almost 3 billion years, only single-celled microbes existed on Earth. All this lush nature we know, dinosaurs, trees, whales, and finally us humans, results from the final act of a spectacle that has been going on for billions of years. The evolution of multicellular life was a revolution, but it took us a very long time to get there. Why so late? Maybe it's not so easy to leap from bacteria to a whale? Perhaps most planets stop at the stage of microbial sludge and never go beyond it? With Earth, it could have been different. We had a few fortunate or unfortunate, depending on how you look at it, events that might not have happened. We have a large moon that stabilizes the climate and tides, and it formed as a result of a cosmic collision. We have the gas giant Jupiter guarding the outer edges, which can attract comets and asteroids, protecting us from too frequent bombardment. Our planet has a magnetic field and a thick atmosphere that protect against deadly cosmic radiation. We have the right amount of water, but not too much. An oceanic world without land might not have favored the invention of fire by intelligent beings. Well, no matter how you look at it, it's hard to light a fire underwater. Then there are the fortunate evolutionary events. The extinction of the dinosaurs 65 million years ago paved the way for mammals and eventually humans. If it weren't for that asteroid, who knows, perhaps the great reptiles would still rule. Perhaps they would have developed intelligence, or maybe not, because dinosaurs were not inclined to make tools. The chain of events leading to the rise of Homo sapiens is full of such dizzying moments. If we were to rewind time and start it over, we would probably end up with a completely different planet, perhaps without intelligent beings. In space, we are discovering more and more exoplanets, planets orbiting other stars. We already know of thousands, and we know that almost every star has something orbiting around it. Many of them are located in the so-called habitable zone, where the temperature allows for the presence of liquid water on surface. One might think, since there are so many planets suitable for life, that life should spread everywhere. But are these distant second Earths really similar to ours? We don't know. They may have toxic atmospheres. They could be covered with eternal ice, or conversely, be hellish like Venus. Some orbit around red dwarfs, stars that indeed live for trillions of years, but often emit bursts of radiation, which could sterilize the planet's surface. Planetary conditions are a delicate puzzle. Perhaps a full set of favorable elements, such as a stable star, appropriate chemical composition, presence of liquid water, atmosphere, magnetic shield, suitable orbit, moon, and so on, occurs only once in many thousands of planets. And from this, only a part will give rise to life. From this part, only a few will develop complex life, and from them, an even smaller handful will produce intelligent beings. And from those, an even smaller number will produce beings that will build a technological civilization capable of radio communication, or, even more so, space travel. You see where I'm going? At any stage of this process, one can be eliminated. The great filter could be hidden in any of these steps, or a little in all of them. It's possible that life itself is not super rare. Perhaps microbes are quite common in space. Maybe even some planets infect each other with life via meteors. This is the idea known as panspermia. Bacteria can survive a journey in space enclosed in rock and land on another planet, spreading life there. If so, one instance in a planetary system is enough for life to spread to neighboring worlds. Some suspect that if microorganisms once existed on Mars, they could have come to Earth or vice versa. Young planets exchanged material billions of years ago after asteroid collisions. But even if microbes crawl here and there in space, they are still a long way from creating a radio or a rocket. Single-celled life could have existed on Mars. It might exist under the icy crust of Europa or Enceladus, but we honestly doubt that under the ice of Europa there are dolphin scientists building rockets, more likely some simple organisms. So far we have not found any indisputable evidence of life beyond Earth, not even primitive, and we've been searching quite intensively from Martian rovers to the analysis of meteorites, and still nothing. Let's look locally once more. In our own solar system, we have 8 planets and dozens of moons, hundreds of asteroids. On how many of them did life as we know it originate? On one in several dozen. It is a small statistical sample on a universal scale, but the signal is clear. Even in favorable circumstances, life is not just any mud that forms anywhere. It requires the right chemical soup, a source of energy, time, stability, and perhaps a bit of luck. Or a whole lot of luck. On this one planet, Earth, in turn, intelligent life capable of technology appeared only once. Apart from us, no species has built a technical civilization. Billions of species over billions of years, and only now are we the first to hold our heads, looking at the stars. On the scale of the universe, it may be similar. Worlds with life are few, and those with intelligence are extremely rare. In numbers, it looks roughly like this. Earth is unique in the solar system, and the solar system is just one of billions of systems in the galaxy. If only every 1,000th star has a planet with life, which is still a rather optimistic assumption, there would be millions in the entire Milky Way. But if only every 1,000th of those planets with life gives rise to an intelligent species, there may be just a few thousand left. Sounds like a lot, but remember, they might be scattered in time and space. They could have arisen tens of millions of years ago in another part of the galaxy and already become extinct before we emerged. Or they might arise only in 10 million years, when we might no longer exist. And that leads us to the next filter, which is... When we talk about time, we mean two things: the moment life appeared in the universe and the duration of a civilization. It's possible that we are simply the first, or at least very early on the cosmic stage. And here I invite you to our episode on this topic. You will find the link to it in the description of this one. The universe is about 13.8 billion years old. Our galaxy was formed a bit later. Our solar system is about 4.5 billion years old. There are stars older than the Sun, but most of the stars in the Milky Way are red dwarfs, which will live for trillions of years. There are also younger stars that have just been born, and the planets around them may still be in the process of forming. Maybe life needs a certain maturity of the universe. Just as you can't bake a cake without ingredients, life couldn't arise until heavier elements were baked in the universe. Perhaps the universe is just now entering a period when intelligent life begins to appear. We are among the first. Our emergence signals the beginning of a new era. From a cosmic perspective, when we look forward, let's say 10 billion years, the Milky Way might be teeming with civilizations. The stars will be different then. Maybe we will merge with the neighboring Andromeda galaxy, creating one gigantic star city. There will be more heavy elements, more Earth-like planets, because each new generation of stars leaves behind an increasingly rich set of building blocks for planets and life. It is possible that the most life in the entire history of the cosmos is yet to come, in the distant future. And we, humans, appeared early, in an era when life is just beginning. In that case, it's no wonder we don't see others. They simply have not yet been born, or are just emerging on distant worlds, and have not had time to anything yet.
Emit. On the other hand, time also acts on the scale of a single civilization. How long will a technological civilization endure?
100 years? 1,000? 1,000,000? It might lead to a paradoxical situation. Everyone is or was there, just never simultaneously. Civilizations may ignite like fireflies, appear, develop technology, and then fade before another distant one can detect their signals. First, if the average lifespan of a technological civilization is short, for example, a few thousand years before something extinguishes it, then the meeting of two in a vast galaxy becomes unlikely. And what could extinguish a civilization? Unfortunately, the imagination suggests many not very cheerful answers: nuclear wars, ecological disasters, pandemics, maybe uncontrolled artificial intelligences, or in other words, self-sabotage. Or cosmic factors, supervolcanoes, asteroid impacts, gamma bursts from space. An intelligent species may also simply change, for example, merge with machines and abandon physical expansion, live in a virtual world, no longer sending any signals into. Each of these scenarios is a potential great filter of the future, something that most young civilizations may not survive. If such a filter is typical, then perhaps intelligent beings have appeared many times somewhere in the galaxy, but eventually they always fall silent. And we may be approaching this invisible wall. All of this might sound depressing, but there is also a bright side. Maybe the filter was actually time. Maybe we are the lucky ones born earlier and have no competition, pioneers of life. Intelligent. Someone has to be first. If we are really the first or one of the first civilizations in our entire galaxy, then we bear an extraordinary responsibility, but also an opportunity. We have before us a virgin cosmos where no one threatens us, or at least so far it seems. It looks. The entire galaxy may someday belong to us. If we play our cards wisely and survive our own threats, we may become that missing link Fermi was looking for. An ancient civilization, which in 1 billion years young beings from other planets will regard as mythical, ancient. If, however, we are not the first, it means that the filter might also be waiting for us. It doesn't have to be some cosmic plague or hostile aliens lurking to eliminate competition. That's more the domain of science fiction films. More realistically, it's our own wisdom or foolishness that will decide if the great filter is overcome. The Fermi Paradox may pose the question of whether we can avoid the fate of those who possibly didn't make it. Will we avoid self-destruction before we become interstellar? Will we resist the temptation to close ourselves off in our own digital paradise, ignoring the stars? Or maybe we just need time? Perhaps in a few centuries, we will fill this silence with our own voice, sending life and consciousness throughout the galaxy. The Fermi Paradox remains unsolved, but the great filters give us a framework to think about our situation. Either we are the unique winner of a series of cosmic lotteries, from the laws of physics, through the emergence of life, to surviving dangers. Or we are sitting on a ticking time bomb and the hands are moving. Either way, the silence of the cosmos teaches humility. Instead of forcefully searching for aliens, perhaps we should focus on not disappearing into the darkness ourselves. Because if we truly are alone, it is even more worth caring for the spark of life we carry. And if we are not alone, then maybe our time to meet just hasn't come yet. Look at the stars this evening and think, are we the first or maybe the last? Does the silence around mean that in the vast ocean of the cosmos, we are the first to ignite the light of reason? Or perhaps somewhere long ago, someone had already burned but faded before we could notice. And now it's our turn to illuminate the void or share their fate. We will be solving this mystery for a long time. Perhaps one day we will receive a signal from the stars and the Fermi Paradox will cease to be a paradox. But for now, the future is in our hands. And perhaps we ourselves will become the answer to the question, where are they?